Thank you everyone for coming out tonight for this Qdrant and Neo4j event. We're going to be talking about something called MMR on the Qdrant side tonight, and that is a way for you to basically diversify your search results. So before I get into all that though, I just wanted to shout out this hackathon that we currently have going on. This is the, oh, can I open it? Let's see. This is the Think Outside the Bot virtual hackathon. We've got some cool partners that you can see there. Crew AI, Neo4j, who's here, Mistral, Superlinked. And basically we're asking people to use our vector search engine to build something that isn't a chatbot. We know that a lot of people are building RAG chatbots, and of course they're useful, but we're looking for things that are a little more creative than just the normal RAG chatbot. So that's why we introduced this Think Outside the Bot hackathon, completely virtual, and you have until September 16th to submit. As well, if you are from Berlin, and you'll be in Berlin on the 26th of September, we're having our Vector Space Day with some really cool partners. So maybe I can find an image here. Yep, we've got AWS, Microsoft, Vultr, Base 10, Dust, Llama Index, Neo4j, Google DeepMind. It's going to be a really packed day where we talk about search specifically with vectors. So with that out of the way, let me pull up my slideshow. And as I mentioned, today we're going to be talking about MMR, which is maximum marginal relevance. This is a re-ranking algorithm to make sure that you get diverse results. So I'll start off with the Qdrant intro, then we'll do a dive into MMR, and finally I'll have a demo before I kick it off to Nia Macklin from Neo4j. So variety is a spice of life. Everybody knows this, right? But in search, and especially in e-commerce, variety is really important, because if we take a look at a normal search from an undisclosed site for black jacket, you'll notice that you basically get 5 of the same exact bomber jackets. They're slightly different in terms of the zipper, maybe the padding, maybe the color of the inside. But at the end of the day, if I want a black jacket, I probably want to see results like this, right? Where we have a bomber jacket, we've got a hoodie, we've got like a sports jacket, we've got a raincoat. There's variety in these responses, right? So when your user is going to search, you're not just going to get these very same results. And that's important for a few reasons. First of all, agentic RAG is obviously a huge thing right now. And you can imagine if you had your agent do a search for clothing and all it returns was this, well, your LLM, when it gets that context, might think that the only black jackets you have are bomber jackets, because that's the only thing that the search retrieved. Whereas you do have this diversity. So for certain use cases where you're going to be looking at items and you don't want duplicates, this is where MMR is going to come in handy. But before we get into the MMR algorithm, we first have to start by talking about what is Qdrant. Qdrant is a vector search engine. And what does vector search engine mean? Well, it means if we take a look at this figure in the top over here, vectors have a magnitude and they have a direction. And it's very easy to visualize this on a, it's very easy to visualize this on a 2-dimensional plane, because we can just draw a line that goes in a direction. 3-dimensional starts to get a little wackier because we also have that z-axis, which is depth, but you can still picture in a 3-dimensional plane, you could go either direction, up, down, etc. Now, vectors typically have hundreds, if not thousands of dimensions. So we don't really have the technology to visualize this yet, but you can imagine in your head, if we had thousands of dimensions, that would allow us to capture nuances of information. And what you can do then is kind of visualize it like this, where you group certain vectors in the same place. And how this happens is through the embedding model, which is trained on a neural net to be able to take your information, your video, your audio, your pictures, your PDFs, your raw text, and turn it into numbers, aka vectors. So if you take a look at Qdrant at a glance, once again, we're vector search engine. So you can differentiate Qdrant from a traditional ACID database, because traditional ACID database cares about consistency, focuses on ACID. Qdrant, on the other hand, is going to focus on vector search, hybrid search, being distributed and resilient, because of course, at the end of the day, you want to get to prod. We don't really care if your demo works in the POC stage, and as well as filtering. So if you go back here, you can see we're really engineering this to be a vector search engine, and we want to highlight the differences between a vector search engine and a traditional ACID database because the vector search engine is a completely new paradigm, and we're also not a database, right? We are an engine for you to plug in documents and be able to search no matter what the modality of it is, and especially this unstructured data. And at the bottom there, you can see some of the things that we like to highlight. I would highlight performance-centric and scalability-oriented. We work with billions of scales. If I go back to the Qdrant website, you can see some of the companies that we work with, and you can imagine, well, these are all companies that have a bunch of data. They need to search it. They need to make recommendations. They need to do something with that data at a large scale, right? And that's where Qdrant really shines. So going back to the slides, another thing that we really want to focus on is that Qdrant isn't just a bolt-on or add-on to your database. It's actually built from the ground up in Rust. It was built in-house, actually. The creators of Qdrant created Qdrant because they were working on databases for AI stuff, and they just weren't getting the performance they wanted. So they went to the lab, they built it in Python, and then once we started becoming a real company, they actually refactored it all to be in Rust specifically for speed for vector search. So we're really all about search workflows. And once again here, we have some of the highlights of Qdrant: hybrid search, filtering, vector search. And this distributed and resilient part is really important because when you get to prod, you're going to need things like multi-tenancy, sharding, replication. It's not just going to be you on your local host. You're going to have to deal with different levels of hierarchy as well as different access controls. And of course, that replication, making sure that if something does go wrong, you're good to go. And then in terms of advanced features, today we're going to be talking about the MMR re-ranking algorithm, but we also support binary, scalar, product quantization, 1.5-bit quantization, 2-bit quantization, multi-vectors. So imagine you upload a video and you want to separate out the vectors for the audio and the transcript and what's on screen. Because maybe you want to search through your video by a song, or maybe you want to search through your video based on the transcript. By using multi-vectors, you could literally isolate those two, or you can combine them. And we have a quick example here of what MMR does for you. On the left, we have a food search for kebabs. On the right, we have a food search for kebabs. I think it was actually donor, sorry. And you can see here that if we just do similarity search, what we care about is relevancy. So we're going to get a lot of the same image. But when we do similarity search with MMR, we don't get any of the same images. And you can combine that with the filterable HNSW. So for example, we could have filtered this for foods under 500 calories or maybe by price, etc. So the cool thing about Qdrant is being able to combine your unstructured data with hard filters so that your users or user can get the best search possible. And of course, as I've mentioned, we're all about production. We're built in Rust specifically to be fast and prod. We support HTTP, gRPC. So if you need to use us in even the SDKs we don't support, like C++, you can just do that. We do support Python, TypeScript, Rust, and Go. And we also make vector search affordable, right? Because we focus on vector search, so we make sure that things are not too expensive for our users. In terms of some use cases for vector search, if you're not familiar, if you are, then maybe you'll learn a new one. But obviously, search systems is the biggest, right? Information retrieval. The second, recommendation. So what if I can just dump in my entire product catalog and instantly get good recommendations? Anomaly detection. So if you are imagining a factory process, what if we took a picture of what the car is supposed to look like at every step of the process, and then we can flag when there's something wrong with the system because, hey, this car that came out, it doesn't look like the pictures of the other cars that we knew went on to be good products. And then finally, of course, RAG and information assistance. For example, in an agentic workflow, maybe you're going to give the vector database as a tool to your agent, and then it can go in there and do a search, retrieve results, and give you an answer. In terms of specific verticals, legal tech, e-commerce, really big right now. But of course, we also work in media, healthcare, fraud, bio, etc. And then getting started with Qdrant, of course, we have a pretty big ecosystem. We are LLM agnostic. We're embedding model agnostic. Today we're here with Neo4j. Thank you for coming out, Neo. And you can also see these other companies that we've partnered with that you can use our product with, among others. And if you're getting started, we recommend you check out the free 1 gigabyte that you can get on Qdrant.tech, or you can just use it open source. So one of the cool things about Qdrant is you know exactly what's going on with your code because you can use it open source via GitHub. And when you're ready to scale out, you just have to change one line of code that goes from local to cloud. And our vision, we are the only open source database built entirely in-house and in Rust. So that shows you that we committed early on to having the most performant product, and it's paying off now in terms of speed, accuracy, cost, and also making sure that it fits with any deployment type. So that's what I mentioned earlier with this these different deployment types. When you're ready to make your switch from local to cloud, it's literally just one line of code where you're going to give us your API key and you can make the switch. So all the code outside of that stays exactly the same. We make it really easy for you to deploy your stuff on different platforms. So now let's talk about MMR. Before I talk about MMR, you have to talk about where we started, right? And where we started was dense top K retrieval. That's really the foundation of vector search. What's the deal there? Well, we're going to encode our data. So we've got documents and we've got queries. We need to turn those into numbers. We're going to use an embedding model that's trained on a neural net to do that. Then we need to compute the similarity. So you've got cosine similarity, dot similarity, L2 similarity. Today we're going to be using cosine, and that's usually what we recommend for starters. But for your specific use case, maybe you have a different distance metric you want to use. And then finally, returning the results. So you can actually edit even the amount of results that come back. Sometimes you just want the top one. Sometimes you want the top 1,000. It depends on your use case, of course. Now, what's the problem with that workflow that I just showed you? 3 pretty big problems that we can identify off the top are duplicates. So if you're ever searching through, for example, PDFs that you have chunked, if there's too much or too little overlap in the chunking, then you can return duplicate results. And then all of a sudden your system isn't going to be effective because if it's a clothing website, for example, you're going to return all of the same jackets. If it's searching through PDFs, well, you don't want to just return 5 chunks in a row of the same PDF. You actually would want a variety of results because you already know what the PDF is based on the title. We're just using the chunk to find that specific piece of text. And then even near duplicates. So it doesn't have to be an exact duplicate. A near duplicate isn't very helpful to the user either. Coverage gaps. So this is kind of what I was talking about with the agentic RAG. If you have an agentic RAG system and one of the tools you've given it is vector search, and it's returning 5 of the same result, your LLM is going to think that those are the only 5 results. Or even if you do 500 and it's 500 of similar results, your LLM will think it's all 500 of the same results. When in reality, you might have results that are relevant, but they weren't picked up because you weren't doing anything to deal with the diversity. And then finally, RAD failures. So that's bringing these two together. You're going to have brittle answers that you can't really trust because you don't know, hey, did my search actually get a diverse representation? Your RAG answer is wrong, hallucinating in the sense of like, it might tell people you don't have a black bomber jacket when you really do because it didn't find it in the search. So how does this work under the hood? Well, here we have the actual formula that we decided to deploy. And the important part of this formula is this DJ, but the rest of it is S is going to be our already selected items. And the very important part here is going to be this 1 minus lambda, right? So what you can see here is the actual piece of the equation that's going to give us the MMR is this 1 minus lambda. And I'll get into more detail about that, but what you want to take away from this is basically we're going to first fetch the results, and then we're going to penalize every result after the first one. So the first result is always the most relevant, right? But after the first result, so for the second result, instead of just getting the second most relevant result, we're going to penalize it based on how similar it is to the first result. And then we're going to pick that result. And for the third, we're going to do the same thing, but looking at the second result. So we're going to create kind of like a waterfall. And how much we punish it depends on this 1 minus lambda function, which is going to allow us to punish less or more depending on how diverse it is. And then here we have a visual, right? So we have our query here in red. And the way that it usually works in vector search is we're just going to grab the nearest results to the query, right? Because going back to this slide right here, imagine if our query ended up right here. Oh, I can't click. Imagine if our query ended up right here, we would just grab in a circle around here, right? And of course, this is thousands of dimensions, so it's not exactly one-to-one, but imagine just that concept, right? Now, the difference with the MMR is, what if we didn't just grab the nearest ones? We first grab this one because it's the closest, but then we're throwing out these two because we're like, ooh, it's way too close to that first result. Okay, we go here. Boom, we get that result, we throw out these two, we go up here, we go up there. So even though the points that we're returning might not be the most relevant, we can ensure that we get a diverse group of points, which is ideal for things like e-commerce, shopping, or even looking up chunk PDFs, right? So the 3-step process in Qdrant is, first you're going to have your ANN retrieval, and in your HNSW, there's going to be this K_C parameter. And what you can do with this K_C parameter is set the candidate size. So the candidate size is how many documents you want to retrieve for re-ranking. So imagine for a second, in the clothing demo, I'm returning 20 results to the user at the end, and my candidates is 100. So you want to make sure that you're getting more candidates than you actually return results, because otherwise there's nothing to diversify. And you want to make sure that that number is larger by a good margin than the top results, because once again, even if you diversify on 21 results, but you return 20, it's going to be the same results, right? So you want to make sure you've got a nice multiple of however many you want to give at the end in your candidate selection. And the candidate selection is basically something that you can do with a dumber model, because you're going to be re-ranking. So the idea here is you could save time by first fetching 1,000 candidates, and then you use a smart model that's a re-ranker to get the top 20. So we start off with that ANN, then we do the MMR re-ranking, which is this formula here, and then finally we give the user those top results. So one thing to keep in mind here is that the process is not going to give the user the most relevant results. So when you're doing your testing, or even when your users are using the website, they might be like, hey, this isn't the most relevant result. You might have to tune your diversity parameter, which is that lambda that I talked about in this formula. The lambda is the diversity parameter, to make sure that you're actually getting the right results, right? So just keep that in mind. It's not going to be the most relevant results. It's going to be the first most relevant result, and then after that, we're basing it off of diversity. So a few things to keep in mind: the candidate pool, that's that K_C. Make sure you've got a big candidate pool, or certainly bigger than the results that you're returning. Second is the diversity parameter. So that's that lambda that I mentioned. If we have it low, we're going to have less diversity. It's going to be more focused on relevance. If we have it high, it's going to be more diverse, but your results are going to be less relevant. So we recommend starting off with 0.5 right there in the middle, that sweet spot, and just see how that gets your results. And it goes from 0 to 1. So you can have it all the way turned up to 1, or you can have it all the way turned up to 0, or sorry, completely off at 0. And then finally, performance impact. So obviously, there's no free lunch in vector search. So anytime you're doing re-ranking, that's going to take up performance, right? Because instead of just sending it to that dumb model for the prefetching, there's a second step now. So just keep in mind that there's going to be some performance impact there. Data quality considerations, I've actually talked about a lot of these, so we don't have to go through all of them, but chunking, if you are doing this with internal documents, and let's say they're PDFs, and you turn each of your PDFs into 20 chunks, make sure that you're A, chunking correctly, and B, you might want to actually filter by document, because if you just get 20 chunks from the same PDF, that might not be very helpful. What you might actually want is 20 chunks from 20 different PDFs. Depends on your use case. PDFs can get pretty crazy. A lot of them do have different information, but that's just something to keep in mind, is you might want to filter at the document level. Got hybrid retrieval. So hybrid retrieval is going to combine dense and sparse, right? So you have to decide, where are you going to be doing your filtering? Do you want to do it with the dense embedding, with the sparse keywords, or do you want to do it afterwards with some fusion? Either of those techniques are going to have their pros and cons. Today, we're going to be using it on the dense embeddings. Document deduplication, that's what I actually just talked about, where if you don't want fragments from the same source, you can actually filter by document to make sure that the same document isn't showing up. And then you can also have a filter first approach. So in the shopping demo that I'm going to show you, for example, we can filter first by gender or by clothing type and then do MMR, right? So that we make sure that we're getting blouses for women that are black, but a variety of them. Or you might just want the user to search for elegant dress and give them a variety. You don't care about the gender, the color, the type of clothing. So I'm going to show you a demo. Let me see how I'm already up on time. Okay, so let me show you this demo here. We're going to say casual summer wear. And this data set is let me pull up the data set just so you know. It's the deep fashion data set. And this is a really good data set because we have these images and we also have people wearing the same image but maybe in a different pose, right? And in addition to that, we have this cloth type as well as gender. But what makes this good is the images actually aren't labeled in terms of like this is a dress or this is a tank top or whatever. Oop, I shouldn't have clicked that. I made Hugging Face mad. This is just listed as item 1 or item 0. So you get to see the power of Qdrant here, where if I go back and I search for casual summer wear, and you see I have my MMR diversity slider, I'm going to put it at 0. So we're just focused on getting the most relevant results. What you'll see is already in the top 3, there's a duplicate. Why? Because this is the same piece of clothing, but it was shot at different angles, right? It looks like this one's zoomed in. So if I keep scrolling, you'll see, oh, wow, sure, these are casual summer wear, but we're getting like way too many duplicates. And also, all of these results are pretty similar, right? So users don't really like duplicates, and they also don't like similar items, especially when you're talking about an e-commerce use case, right? Because if you're coming to shop and everything at the store is the exact same, you're kind of like, hey, this store sucks, right? So now we're going to turn up the diversity and run this search again. And what you see here is not only do we get some items actually for men, which I don't think we did in the relevance one, there's not going to be any duplicates here, right? We've got a nice variety of summer casual wear. Now, as I mentioned, we can actually filter this. So I'll turn the relevance down again, and I'll just do men and search. And you can see, boom, we're just going to get clothing that was gendered for men. And we can even go crazier by filtering on the, by filtering on the clothing type, right? So here, we can combine these two, get shorts for men, but then we can also mess around with the diversity to get the user the result they want. And you can see here, the score for this one was 281. The score for this one is 257. So like I mentioned, we're not going by score. We're going by this diversity, which is why this one, even though it has a score of 222, is actually coming in second. So this is a practical demo that we're going to open source. It uses 10,000 different images from that deep fashion, where you can just search and mess around with the diversity to kind of see how diversity impacts your results. So going back to my slides, what is the impact of that? Well, obviously, if you're an e-commerce website and now you can get more diverse results to your users, what we found is that you get much better conversion rates because users like to see a variety of stuff. What is the exact diversity metric you should use? Like I mentioned, we tell people to start off at 0.5 and go from there, but you have to see for your own use case. 0.1 might be enough for you, right? Or you might have to go to 0.9, depending on what kind of data you're dealing with. So in terms of pitfalls and solutions, embedding collapse, I'll start there because if your embedding model isn't, or if your embeddings are too similar, this isn't going to work, right? So if you're not using the right embedding model, or if you're garbage in, garbage out, if your data isn't leaning itself to being embedded well, then you're just going to diversify, but diversify over what? So you need that initial good data. Insufficient candidate pool. So that's that KC metric where if we don't have enough candidates, then how are we going to diversify? Result ordering, that's mentioning just that it's not going to come out by score, it's going to come out by diversity and over diversification, right? There is a limit to, if I type in casual summer wear and you give me a winter coat, I'm not going to be happy, right? And then in terms of some advanced things that you can do, you can group by the source. So that's, for example, grouping by the PDF as opposed to grouping by the chunks to make sure that the same PDF doesn't show up in your search, even though you're only surfacing chunks. Multi-vector collections. So if you upload a video, you can use a tool like 12 Labs to actually take out the video, which is what's on screen, the audio, which is the sound that's going, as well as the transcript. So now, if a user's on a site like YouTube or on any video search site, you could actually diversify the results by what's on the screen, what's the audio, or what's the transcript. Or you can combine them all to diversify through all three. So putting these two things together is a pretty powerful metric, especially when you're doing A/B testing and seeing like, okay, if someone just watched a video that talked about Qdrant, should I recommend them another video that talks about Qdrant? Or should I worry more about what's on the screen? Or should I worry more about the audio, right? Maybe what they really want is songs. So make sure that you're representing the right songs. So that's it on MMR, but before I kick it off to Naya to talk about Neo4j, I just wanted to give a quick example of how GraphRag works with Qdrant and Neo4j. So the example that I love to use for GraphRag is, let's say you had 25 factual sentences, and these are sentences about Alice, Bob, Carol, and Dave. And you wanted to know, how is Bob connected to New York? Well, none of these sentences are literally going to tell you how Bob is connected to New York. You'd have to read through them and start to build a graph that connects all of these people together in order to get your answer. So what you can do with Qdrant and Neo4j, this is a simple architecture graph, is take your raw data, create an ontology that's going to use some kind of large language model. You could use hierarchical, for example, or community of communities. Then we're going to send that to Neo4j. They're going to graph it up for us. Then after it's been graphed, we're actually going to send it to Qdrant, but we're going to link it based on the IDs of the nodes and edges. That way, we can combine the power of GraphRag with vector search. And then, of course, we've got our vectors via our embedding model so that we can embed both the document and the query, get them both out, and we can answer, hey, Bob is connected to New York via Carol because they both worked at that company. All right, thank you very much. That is the Qdrant piece of the presentation. I'd like to welcome Naya up to the stage for the Neo4j section. And once again, if you have any questions, feel free to just grab me. Thank you.
All right, so welcome to my talk, everyone. My name is Naya Macklin, and I'm going to be talking about vector plus graph, which is better together. So providing knowledge to your AI agents and LLMs. All right, let's get into it with a quick introduction. So again, my name is Naya Macklin. I'm a senior developer advocate at Neo4j. If you've heard of Neo4j, welcome. Thank you for coming, my friend. But I care about graph algorithms, and GraphRag, and I often do talks about them as well. I also care about ethics, governance, safety, and responsible artificial intelligence. I know a few people are like, yeah, we don't need that responsibility piece, just throw that out the window. But I think it's actually very important. This talk is not about that, so don't worry, we're not going to get into it. But if you ever do want to get into it, feel free to scan the QR code, and you can find me on LinkedIn, and we can actually have a real conversation. All right, so I've taught at universities, high schools, and nonprofits at different courses and have different conversations with folk. But, so just a few, like making sure we're all on the same page. I know most of y'all are engineers yourselves, so like, yeah, that's right, rowing together. Let's get started. All right, so just a couple, just a little bit of common knowledge or common vocab for folk. So a knowledge graph. I know lots of people, what is a knowledge graph? People raise their hands, they know what a knowledge graph is? Okay, great. I see a couple hands. Wow, that's actually fewer than I thought. Who can explain what a knowledge graph is? Do I see? What are you doing? Well, I guess then I'm glad that we're actually having this conversation. So a knowledge graph, for those who don't know, this is an example of a knowledge graph. But a knowledge graph is an is an organized representation of real world entities and their relationships. So it's typically stored in a graph database, which natively stores that relationship information. So the relationships between the data entities. So entities, or nodes, as I'll often refer to them as well, in a knowledge graph are usually things like objects, nouns, people, place, things, right? And then we also have relationships between those nodes, which capture the context of that information and the meaning of how that information is connected or how that data is connected. So that's a knowledge graph. Knowledge graph again. So I'm a node. My new friend is a node. We have a relationship. Boom, we made a knowledge graph. Simple, right? In the simplest terms. Okay, so the normal RAG pipeline, I'm sure most people in this room know the normal RAG pipeline. I can totally skip this. If I actually see some people put in there trying to get a little screenshot, so maybe I'll just go over it just a little bit. In a normal RAG pipeline, this is a sample architecture. You're going to take PDFs, for example, chunk them, and then index those chunks using a text embedding model, just like my boy Thierry just mentioned. And then we're going to use that same embedding model to fetch the top K or top X number of relevant documents, pass those to an LLM, and then that LLM will give you the final answer from those documents. So that's a normal RAG pipeline. So today I'm actually going to be talking about graph RAG. Many of you have heard of graph RAG. Let's see hands for folk who have. Yes. Okay. All right. A good number in the room. Again, who can explain it? I'm literally going to pass the. Okay. We got one person over here.
So I built my first graph RAG on the Game of Thrones wiki page because I was finding it very hard to follow the series. So that's how I answered my question.
Thank you so much. That's very exciting. You didn't tell me what graph RAG was, though. Ooh. That's okay. But so for folk who don't know, what is graph RAG? Graph RAG in its simplest form fundamentally is RAG, but where the retrieval path also includes a knowledge graph, right? Pretty simple stuff. So as illustrated here, another architecture as well. So you can use a knowledge graph in your retrieval path, which also allows you to use graph-based retrieval patterns, such as graph-enhanced vector search and other graph enrichments. So graph RAG, I always say, graph is most beneficial when it's used as an added layer onto your vector architecture, right? So you get the benefits, just like Thierry mentioned from Qdrant, the benefits of both vector search and graph traversal. And we'll get into that here. So the benefits of graph and vector. So vector plus graph approach usually creates massive improvements, right, for a regular dev team's applications. So some of those benefits include this higher accuracy piece, which gives you more accurate and more complete answers, which is a runtime or a production benefit. And then once you've created that knowledge graph and understand graph RAG, it's easier to build as well. So it's easier to build and then subsequently maintain your graph RAG application, which is a development time benefit. And then lastly, a lot of the benefits that people see when they're using graph plus vector is that they see better explainability and traceability, right? And access controls, right? So this is important for governance and audits. So we're going to dive into these just a little bit. So this higher accuracy piece. Every time I talk, y'all, I always will have my resources, right, and my proof down below. So please feel free to scan the QR code. That'll take you to this paper. But one of the biggest benefits of adding graph to vector is this piece about higher accuracy or the quality of the answer, right? So this is one example from data.world, which is out of many different white papers. Feel free to scan the QR code, like I had mentioned, to read the white paper for yourself. We do our homework over here, all right? So, but this paper found that when they pulled out 43 different questions, that they found that from that specific sample size, the average response quality was 3 times higher on average if they use a knowledge graph in addition to vector search. So this is not new information, right? So this white paper had come out in like 2013. Sorry, not 2013, November 2023. So it's well known that knowledge graphs and the additional context that knowledge graphs provide, responses for the LLM output, really benefits Gen AI applications. So we talked about a little bit about higher accuracy. Now for this easier development piece, why, right? So the second reason why we hear many people like to use graph plus vector is because once they've moved past that initial learning curve about learning graph technology and graph RAG, they have said that it's become an easier development process. So for example, say we have this phrase called phrase apples and oranges. Apples and oranges are both fruit. Ooh. So apples and oranges are both fruit. And if we represent that in a graph space, it's actually relatively easy, right? So there's an apple node, and there's a relationship node, also called an edge. And then you also have a fruit node, right? So apple is a fruit, orange is a fruit, simple. So it helps make data a bit more human readable versus viewing that in the standard embedding calculation. So you can also run similarity calculations, both explicit and implicit data, and more explicit methods for structural and taxonomy-based similarity searches on graph nodes, or using implicit or sub-symbolic similarity searches like Euclidean or cosine similarity. So then, last piece about easier development is that you then are able to run search algorithms on both using explicit graph traversals and then the more implicit methods like ANN or approximate nearest neighbor search as well. So instead of forcing yourself to use implicit and approximate searches, if you add a knowledge graph onto your retrieval path, that exploration of said data is actually easier. And that's going to move us to our third benefit of using graph plus vector, which is that explainability and governance piece. So finally, being able to traverse the graph and trace the source of the LLM's output allows us to better explain the output that the LLMs create, so which is necessary for auditing and data processing purposes. But don't believe me? That's perfectly fine, right? I always have this slide. Prove it, right? Prove it. So this, for example, right here is a seminal white paper from a staff software engineer at LinkedIn, Zhentao Zhu, and their team titled Retrieval Augmented Generation with Knowledge Graphs for Customer Service Question Answering. So definitely take a picture of that paper and read it yourself. So this paper tested out GraphRag to see if it was actually beneficial for the customer service question answering process. And they found that by including a knowledge graph into their pipeline, into their normal RAG pipeline, they saw a decrease, okay, a decrease in per issue resolution time of 28.6%, which is a significant improvement for vital customer support. I see some pictures being taken. Cool, cool, cool. All right. And then we also have another white paper from the Microsoft research team from the Office of the CTO on the benefits of using graph plus vector over traditional WAG for QFS, which is query focused summarization for LLMs. Highly seminal paper as well. Please feel free to take a picture and read the white paper yourself. But, you know, all of this research on graph plus vector doesn't stop here. So this is a small sample of a lot of the research that you can find. Feel free to take a picture, but this information, for those who want to actually look it up, can be found at graphrag.com/appendices/research. So all the different research on GraphRag, its benefits, you can read all the white papers there. Oh, sorry, I saw some people. I'll also have this slide at the end as well. So overall, there's lots of benefits for using GraphRag in your GenAI app development. But how does this help with agents, right? Agentic development. So just taking a step back, for those who aren't aware, I'm sure many of us are, what's an agent? An agent is an application that uses GenAI models to think and act towards specific goals, for example. So they automate complex enterprise workflows where you might have rules that aren't very clear and are not necessarily defined programmatically. So they can use reasoning and planning to determine which steps to take next, for example. So they often utilize tools called function calling which will then allow an LLM to do anything that you can write a function for, right? So to access data, take actions like querying a database, calling an API, whatever. So how they do that is through this wrapper around an LLM, and you're going to ask that LLM to prompt in a very particular way. So you have to start by adding background context and instructions on what you want it to do. And you always ask it to respond back with a thought, an action, and an observation. So we're going to start with a thought, right? What does this agent actually need to do? So we're then going to move to an action, right? We're going to take a predefined list and ask it to pick from one of this number of tools, and then we're going to take it, make it. We're going to make it choose from a list of these predefined tools and then specify whatever the necessary parameters that we're going to need. Then we're going to pause, all right? I'm talking fast. Then we're going to pause, and we're going to execute whatever tool, either the function call, API call, what have you, to like a call to the database, and then we're going to wait to see what those results actually are. After that, we feed all that information back to the LLM as an observation and as the LLM ask the LLM to continue generating. So that's the cycle, right? Thought, action, observation, thought, action, observation. And this is the nature of agentic applications, right? We're going to use that LLM to then take concrete actions beyond the simple text generation. And then those agents are going to plan and reason and execute tasks using target models, or like function calls, API calls, right? Which are orchestration frameworks, which also allow that agent to plan and to execute the processes when invoked. And this is an excellent picture to take as well. The next one I'm going to show you is actually an architecture diagram, which you're going to be able to use when you're using Graph, Vector, Neo4j, or just Graph in general, to build out your AI apps. So this is what the agent architecture will look like when you're also incorporating a knowledge graph. So you're normally going to have the agent itself, which is the teal box, and then you're going to have a UI, which you're going to expose to that agent as a knowledge assistant, for example, with semantic search, automation, personalized experiences, whatever. Then you're going to have your AI model themselves, aka the embedders and the LLMs. You also have your data sources that you would use for retrieval, which could be both structured and unstructured data, right? And that data, all of that data is then going to be ingested into the knowledge graph, which your agent can then access that knowledge graph through tools like MCP, Model Context Protocol, which is right now the golden standard for connecting tools and contexts in language models and the agent. So it's also going to be able to access other forms of source data. But the benefit here for agentic applications is that by adding this knowledge graph plus vector data store to the pipeline paired with this larger MCP architecture, the schema of the knowledge graph is now going to provide that contextual information that's necessary. And when you break down a user question or a prompt that they would normally input into the system, you start to see very clear and direct logical flows of information. All right? So I can get into a lot more detail, but again, I just wanted to put up this slide for all the resources and all the white papers that you can read in order to learn more about how graph plus vector impact AI applications, the good, the bad, the ugly, all the benefits, all the things that people are saying, you know what, this actually is not the right solution for us. You're seeing it all in this research here. So if you would like to learn more, lots of different places. So we have a Graph Academy completely free, online, interactive. This is not just you sitting and listening passively to a professor talk to you. This is hands-on keyboard, okay? So hands-on keyboard, interactive interface called Graph Academy, and it's completely free for anyone to sign up and learn more about GraphRag, building AI agents, building tools with MCP, how all of that works with and on top of Vector. So GraphRag is an excellent place to learn more. We also have a fully online, completely free as well, developer conference that's happening on November 6th. And so last year we had 12,000 people attend this conference. It happens for 24 hours. So for those who are awake at 1 a.m., the conference will still be going on. And we have about 170 different unique speakers. So for those who went to the Graph Exchange, that or know about the Graph Exchange, it's another event that we do every number of months. This is like a massive version of the Graph Exchange where people are sharing their use cases, people are showing their demo applications, their production use cases about what they're building with Graph plus Vector and Graph in general. So this is an excellent place for you to just come and watch, as I mentioned, for free. So the agenda is already up, or will be going up, I think, this week. And each talk is about 15 to 30 minutes long. So highly, highly beneficial. And as well, 80% of the talks are from the community, right? Community members. All right, so lastly, I just want to shout out this incredible new deep learning course that we have with Andrew Ng. And it's actually a 3-hour short course that we have. Free is our middle name. It's an open source graph database, but completely free as well, with Andreas Colliger and Andrew Ng, which is available for you to take on deeplearning.ai. It already has almost 2,000 different likes on LinkedIn. It's a trending course right now, for you to learn about agentic development as well as graphs. All right, that's all from me for now. If you want to talk more, please find me after. Again, feel free to connect with me on LinkedIn and we can chat more about Graph plus Vector. Thanks so much, y'all. Appreciate it.
Okay, thank you everyone. A bit about me. I am Prinkin, co-founder of this AI startup called as Intungle. Now, throughout the evening, we have been talking a lot about ontologies, vector search, graph search, stuff, but the reality is when you try to build some of these to make your agents really work, it really takes a lot of time, right? There's a lot of manual data engineering effort in order to even build a data ontology or business ontology to make your agents work. And that is why what we have done is we as a company focused primarily to build agents which can actually do that for you. So think of it as a bunch of AI agents working together to create your graph rag, to create your, or to structure your knowledge in a way so that your agentic AI use cases or business use cases can work better, can work deterministically with high level of contextual accuracy, right? I'm going to show you two things today. I'm going to show you how we do it through our platform, obviously, which is more focused towards enterprise customers. And then I'm also going to show you for the developer community, how we are opening up some of these agents so that you can build this knowledge just within your IDE or just do a pip install. Okay, so directly onto the tool. Okay, so this is what the tool looks like. This is the canvas, right? Where you get started is really by connecting to your databases or any kind of data sources from where you want to pull data, right? And create that knowledge. Now, let's say for an example, in this case, I have data coming in from a bunch of places like MySQL, Salesforce, Azure, SAP, and stuff. Typical enterprise scenario, okay? Just a moment. I just pin up the sandbox for this demo. Hopefully it works. Okay, yeah, there we are. Okay, so basically you bring in different data sets onto this canvas in the context of this canvas, right? Now, the first thing that you would want to do is basically classify or organize this data into some sort of a structure because they are currently completely disconnected bunch of data sets, right? So that is where the first thing starts. You basically go and do a bit of classification or system topology configuration. However, there's an agent for that. You trigger that agent. It automatically determines the best categories for your data, and it does some kind of a classification. Now, if you want to play around with it, if you want to override it, you can always go ahead and do that. More power to the devs. Well, now in terms of you as an engineer, as a dev, to understand more nuances of this data, you would like a granular view. You can increase the granularity, get a view of, what are the underlying columns or underlying attributes across each data sets, right? But the most important thing is you want to start connecting this data in form of a knowledge. Right now, they are siloed data sets classified into different data domains, right? That is where we go to the ontology builder. Now, in the ontology builder, we have built an intelligence, which is more like think of it as your graph knowledge engineer, which basically determines different heuristics across your data ecosystem and try to pull together a knowledge graph. So now in this case, when I trigger this particular agent, which we call as a link predictor, what it does is it obviously goes through multiple different heuristics and it says that, okay, this is what your knowledge graph looks like. Now, most importantly, how do you build trust on these relationships, right? This is where what we do is we generate a confidence score for these relationships. And this confidence score is derived deterministically. What do I mean by deterministically? While the agent is predicting the relationship or the potential relationships, the determinism comes when you are actually taking the attributes between which the relationships are identified, and then you are seeing an intersection count or overlap, right? So basically, if you go ahead and if you just say inspect ontology, it will tell you that what are the different attributes based on which, so like the health of the data, the number of records mapped across those two attributes, those are the aspects based on which this deterministic confidence score is calculated. Well, now the last piece of the puzzle is, you basically want to make use of this knowledge graph for some use case, right? And that is where you go ahead and start adding more business data or business meaning to it. And then there is a third agent, which basically, when you trigger, creates what we call as a data dictionary or an English language based glossary for each and every attribute within your enterprise, which typically you would sit or data stewards would sit and manually annotate, right? Now, the point is how accurate they are. So, well, if you are a data steward or if you are someone who is responsible of managing a data dictionary, you can yourself go and override some of these if you don't like it, right? For an example, you have this button here which says regenerate. You basically put additional context based on your industry or your company's context. You hit generate and it generates the glossaries based on the context fed by you, right? Now, finally, obviously, you provide some access controls. Don't bother about it at this stage. Just go ahead and publish it. And that is when you start basically using this knowledge graph in form of different use cases, whether for your MCP or whether for your data products. You can even completely eliminate the need of writing any ETL or data transformation pipelines using this tool. And I will show you how as developers you can do it using the open source version on your favorite IDEs. Okay, before I get there, something very important for us is how the power of this knowledge graph becomes important when we kind of club this with vector search, right? So now what you see here is, and I will show you how we can quickly build a data product out of this live, right? So what you see here is basically a different data coming of patients, health records, diagnosis, claims, insurance, etc. Right now, let me try to search some of the attributes and create a data product on the fly. Right. So in this case, if I let's say search for hospitals. So now in the data, there is actually nothing called as hospitals. The data set itself has something called as organizations, which maintains health records of patients. But obviously, it is now finding out from the entire graph attributes like encounters or organizations connected to encounters and then health records of patients which are connected to providers, right? So what we can do here is quickly go ahead, just add the, add whatever attribute I want to the cart. Similarly, let's say if I search for transactions, oops. I think that is where MMR will help. Anyway, so when we look at transactions, it primarily talks about all the claims, all the payments around the claims that has been done by the insurance organizations. So I add it to the cart. Now, as you observe, what I'm doing here, I'm adding a bunch of attributes to the cart, which in reality, a data engineer would have been required to figure out how the mapping will happen, how the aggregation will happen, and all of that. But in this case, I have built this knowledge graph out of the layer where it clearly tells me that how the entire ecosystem is connected. Now, you keep on adding as many attributes you want to this card, and finally you say create data product. You confirm this is your cart. You can further play around with this cart to whatever attributes you want to add, etc. When you hit next, what this does is basically it searches that entire graph to figure out what is the right traversal path. And based on that, it auto-generates this code, which is your actual SQL code that will hit the database in the backend. Now, when you execute this, it goes and sits as an execution job, which is going to execute on top of your data. And if I have to show you what the final output looks like when it completes, it looks like a tabular view, which you would have transformed as a data set for any agent. So imagine you now have an MCP agent which is talking to this graph where you are asking the agent for specific attributes in natural language, and it automatically creates these data products with you with 100% accuracy. Mark my words. That is very important. No one can claim that in the world of generative AI or agentic AI, you are able to reach 100% accuracy or near accuracy or zero hallucinations. But we are able to claim it because we are not basically relying on the agent's ability to make decisions, but we are able to give the agents an intelligence that allow the agent to deterministically solve the problem, rather solve the problem in a probabilistic manner, right? So yeah, so that's the tool just for our devs. So this is the open source repo. We have not yet released it, but I am probably for the first time today showing everyone. It was just the packaged. We pushed the package to PyPy just last night. So this is the repository. All you can do is pip install Intungle. You will get a bunch of tools. There's a help notebook here, quick start notebook here. So if I give you a quick view of how you can build the same thing that I did using the tool through this notebook, right? If you download it. So first, you have to put your, I have put OpenAI key, but pretty much any LLM key that you might want or that you are comfortable with. It can be Gemini, it can be Claude. You can just go ahead and put it. Obviously, first you have to do pip install Intungle. Once you have done it, you can start reading data from any source. So in this case, I have the repository and I have some sample data listed out here. Where did it go? Yeah. So I have this healthcare sample data in form of CSV listed out here. So I am reading it from here, right? Once you read the data, you just basically go and say, build the knowledge or trigger the knowledge builder from the Intungle library. What it does, it runs a bunch of steps. It will take a couple of minutes. It will take a couple of minutes to run certain simulations automatically. The agent will get triggered. And finally, what you will get is this data set. You can read the data set and display it just like a data frame. And when you read it, you will obviously see some of these heuristics which was not there in your data set. So for an example, it generates this metadata like the uniqueness, the cardinality, the completeness, what is the data type it has identified, and this business glossary and tags, which was not there as within your data, right? If you want, you can visualize this as well. Just say kb.visualize. It will show you the actual knowledge graph. Now, finally, how do you create data product? You basically give your ETL config, tell them what is the name of your data product, what fields you want as the dimensions. Just if you guys have used DBT, how many of DBT users are here? Any DBT users? So if you guys have DBT, as DBT engineers, you sit and write the YAML, you sit and define the YAML, you sit and define the model. We are directly generating the YAML of the DBT itself. So if you directly, and I will show you where the YAMLs get generated. So if you directly import this YAMLs, we are over time. Okay, 2 more minutes. So yeah. So if we import this YAMLs directly into DBT, the DBT model or the data product automatically gets generated without your input required to sit and write all those business logics. So fundamentally, if you look at this, right? So when you finally trigger this particular data product builder, it generates this query which otherwise you sit and write, and this query is generated deterministically. I reiterate, it is not done through an LLM. It is done by traversing the knowledge graph that we have built from the knowledge, and the knowledge graph is traversed through Sparkle, and then translating it into a SQL so that it can hit the database and generate this data frame for you. Now, when you build this, you have this models folder where you will actually get the YAML, which will give you all the metadata. For an example, for every table, you will get all these details automatically generated, which otherwise you would create in a DBT. And then also the relationships. So if you take this particular project and import in DBT, you have your ready-made data product ready without writing a single line of code. Thank you.
Hello, this is Yaya, and this is Nihal. We made thinking model better, demonstrably better. We represent them by graph, how models thinking represented by graph. When you have graph, you have all the graph topology. Maybe you want to show them? You have all the graph topology perks like circular reasoning, the lowest distance between 2 points, all the interesting stuff.
Hello, everyone. So basically what we have done is whenever you query a agent, it at present the thinking model gives you a big summary how it came to a solution. But what we have done is we have made it into a graph so you can actually visualize and see if there are any errors. If you're using a RAG, you can see any pain points or anything that's going wrong.
So everyone likes thinking model. They produce better results by rehearsing what they thought and by step validating their reasoning. For here, Nihal have said how far Jupiter is, and you would see how the model have came up with the answer, which is 480 billion miles. You wanna?
Yeah. So we have two LLMs that are working together. So first, our primary LLM is OpenAI's 3.5 Turbo. So we put a query to it. It gives us thinking tags and how it came to the result. And then we have Gemini on top of it, which analyzes this thinking tags and makes it into entities and relationships between how it came to the solution. Zoom. Yeah. So for this query, as we know, like planets are always revolving, and there's no fixed distance between Jupiter and Earth. So it thinks over it and tells that the average distance between Earth and Jupiter. It also take into consideration how far is Jupiter from Sun. Then it calculates based on that.
So you could see the steps it took. So implicitly, we wanted to have the distance from Earth, but we didn't explicitly say it. So you'd see the model thinking about, oh, we are on Earth. The distance is either in miles or in kilometers distance. Jupiter, this is just thinking where Jupiter is, the sun, base of the sun, it's a planet. At the end, it'll give the actual results, which is having all these thoughts and ideas together. You wanna add anything? Maybe we should show the other graph.
Yeah. Yeah. Yeah, so we are using Gemini to make it into entities and relationships. So it gives OpenAI gives us thinking tag how it came to the solution, but Gemini then reasons it out and makes it into entities and relationship, and then we put it into Neo4j and we visualize it. So we made the complete front end for it, how to visualize Neo4j. Any doubts or any
You
questions?
could have it solve any of your philosophical questions, like how hot is too hot, and you'll see the reasoning.
Delete and start. It's per query, because sometimes the queries, the conversation won't have a relationship, because we use LLM for same chat for different things. So that's why it's query based. So it creates separate graph for each query.
Yeah. So why did we do this? Because thinking model can take forever. We all like thinking models. So what's the shortest distance that give us the most quality? And how could you represent it in graph? And then how do you improve upon that? This is your answer. This is what it's seems to be very complicated question. So if you guys have any existential question, feed it to this. You'll see the chain of thought. Maybe you'll improve upon it. But yeah, graphs are cool. Thinking models are cool. So yeah, yeah. Let's try it. The issue with LLMs are they're not, as you know, they're not designed to solve mathematical questions. Yes, modern Claude, Anthropic, OpenAI, they actually call a calculator. They're yep. Let's. We've never tested this. You'll see it in real time, I guess. It.
Yeah. The battery died, but no.
It's not the right, yeah.
Right. We use React for the front end, and we connected it using Flask.
So, because we were using Neo4j, everything he types, I get it. I get it streamed. And so here's your, that's it. So one last thing is we try to make it that if two graph overlaps, it sees the overlapped part and try to make it better. But since none of the question we asked are related, they're separate, floating in the space. But thank you very much.